Dear students, good afternoon to one and all. So today I'm going to explain the gate class regarding bearings. Okay. So here for gate examination, they will ask one problem on bearings. Okay. So in that bearing, we are going to explain the two methods, two types of bearings. One is called as journal bearing. One more is called as ball and roller bearing. Okay. So maybe the problem may be asked on journal bearing or ball and roller bearing. Okay. So it is very simple. If you remember a few formulas, then you have to solve any problem in our design of the bearings. Okay. First, I will explain what is a bearing. I think all of you know what is a bearing. Bearing is a machine element which can be used to convert relative motion between the two contact surfaces. That is, uh, bearing is a one of the machine element which can be used to allow the relative motion, allow the motion between the journal or between the shaft and bearing, shaft and journal. It is called as a bearing. Okay. So, but here, so generally the bearings are mainly used where we transmit the amount of power or motion from one member to the other member. Maybe it is a direct contact or indirect contact. Okay. But here, so the bearings are also used to reduce the frictional resistance or some amount of friction we have to reduce to provide a bearing in between the two moving component, and also in between the bearing and what you call it as shaft, some amount of the heat will be always generated. So if you're going to overcome or reduce the amount of the heat by supplying a cool lubrication oil, maybe it is a vegetable oil or silicone oil or any grease or any petroleum, so based on the application we are going to supply the type of lubrication oil in between the bearing and the general surface. Okay, now that is the main introduction about the bearing. But one thing you always remember, the bearing is a one of the mission member which can be used to allow the relative motion between the two mating components. Okay. So and also the bearings are used to reduce the frictional resistance or frictional gap between the two surfaces. Okay. So and also in between the two rotating members, the amount of heat will be always generated. Then what we can do, we're going to supply some fluids or any lubricants in between that one. So finally we're going to observe the amount of heat will be observing takes place, right? So next, like this one is called as a ball and roller bearing, and this one is called as a journal bearing. So in generally the ball and roller bearing, we having some few components. This one is called as the outer race. This one is called as inner race. In between the inner and outer race, we are having a number of balls. So depends on the application, we are going to use type of the ball and roller bearing. Maybe it is a needle bearing or any knife edge bearing, single deep groove ball bearing, a double deep groove ball bearing. So like that depends on the type of roller or type of ball, we are going to classify a type of roller bearing. Okay. In general bearing, the general bearings are mainly used only for commercial application, like to resist the only radial load. But in ball and roller bearing, we are going to use both radial as well as the axial load. Okay, na? But in general bearing, we're having a few components like hydrodynamic pressure, bearing cell, journal, and bearing. So the outside fixed component, the outside fixed component is called as a journal. Sorry, bearing. Inside stationary component or supporting member is called as a journal. In between this journal and bearing, we have some gap is there, that is called as a clearance. In that gap, we can supply a amount of lubrication oil based on the rotating of the journal. What happen? The pressure will, the hydrodynamic pressure will be created around the circumference of a journal or bearing surface. Okay, na? So here, but as a design engineer, we are going to calculate what is the amount of heat will be generated, as well as what is the bearing number, and what to call it as what is the amount of friction will be developed. In these three factors, we are going to calculate the in our journal design. Okay, right. So next, See here, application of the bearings. So generally, in application point of view, we are going to use the bearings in each and every application, like piston pin and shafts, crankshaft, camshaft, and any power plants and any steam power plant systems. So automotive industry, automobile industry. So we are going to use each and every application while you transmit the motion or power from the one member to other member. Okay na? So right. So next here the classification of the bearings. So generally the bearings are classified into two types according to type of load, according to type of load, and one more is called as according to nature of the contact. According to nature of the contact, we are going to classify a different types of bearing. So based on the direction of the load, for example, if you're going to apply a load in along the axis, that is called as radial bearing. If I can apply a load in a perpendicular to the axis, that is called as a what you call it as thrust bearing. Okay now. So here based on the type of direction or direction of the load, we can classify two types. One is called as a radial bearing and one more is called as thrust bearing. What about radial bearing? The load the load always acts perpendicular to the direction of the motion of the moving element. Okay na? So and one more is thrust. Thrust means called as the always the load can be acted along the shaft axis. Along the shaft axis is called thrust bearing. Okay na? So next see according to nature of the contact, that is sliding contact. Sliding contact means journal bearing. Rolling contact means ball and roller bearing. Sliding means always the journal will be slides inside the bearing surface. Okay na? So but here one is moving number, one is fixed number. So in our sliding contact bearing, the moving number is a bearing, fixed element is a journal. Okay na? So these combination we called as a journal bearing. Clear? What about roller bearing? So based on the inner race and outer race, the number of balls will be keep on revolution takes place inside the inner race and outer race. We're going to get the motion from the one member to the another member. That is the main thing we are going to analyze or classify the different types of bearings. Okay na? First one is called as according to direction of the load, and one more is called as according to the nature of the contact. Okay, see here. So first one is according to direction of the load, that is called as radial bearing, and one more is called as thrust bearing. Okay, so in radial bearing always the load acts in a perpendicular to the direction of the motion of the moving element. What about thrust bearing? The load which can be applied along the shaft axis. See here, see here. So this one is called as a radial bearing. This one is called as thrust bearing. Clear? Okay. So next, according to type of nature of the contact. That means sliding contact bearing. Sliding means what? See here, all of you. See here, ma. Listen. So here, for example, this one is called as a outer element. This one is called as inner element. Okay. So here, this one is a bearing, this one is journal. In between this journal and bearing surface, we are going to supply lubrication oil. But here, the journal is always slides inside the bearing surface. That's why it is called as a sliding contact bearing. Okay. But in rolling contact bearing, we have a outer race. We have a outer race. This one is called as inner race. In between the outer race and inner race, we're going to make a some hole, some balls. See here, some balls. So these balls are placed inside the outer race and inner race based on the amount of the load. Okay, now in sliding contact bearing, only we are going to apply a radial load, that is called as WR and okay na. But in our rolling contact bearing, we can apply a load in along the axis, that is called as axial load, and perpendicular load. Okay na, one radial load, one axial load. That is the rolling contact bearing. Okay, right. Next, see Sliding contact bearing again classified into three types. One is called as a full journal bearing, partial journal bearing, a fitted journal bearing. So, for example, the bearing can be revolving takes place. The bearing can be revolving takes place around 360 degrees. 360 degrees. That is called a full journal bearing. And when bearing will be completely revolving takes place up to a angle of 360 degrees, that is called as a full journal bearing. If the bearing will be revolution takes place only 120 degrees, that is called as a partial journal bearing. Both are same. In partial journal bearing, fitted journal bearing, the angle is 120 degrees only. Please remember, it is very important bit. So if it is full journal bearing, the angle is 360 degrees Celsius, sorry, 360 degrees. Okay, if it is completely revolution takes place, that is full journal bearing. If it is 100 degrees, that is called as a partial journal bearing as well as the fitted journal bearing. But these sliding contact bearings, we are going to use a steam engine, the steam engine. So these journal bearings, this sliding contact bearings, mainly we have to use only for a steam engine. Clear? No doubt. Okay. Next, see, what is the thick film lubrication type of? Why? Because of here, if we're having a, this one is a journal and this one is called as a bearing. Okay, so in between this journal and bearing, what happen? If journal will be keep on revolution takes place, some amount of the heat will be generation takes place. Okay, na? How we are going to observing takes place by supplying a lubrication method or type of lubrication if you're going to use to observe the heat as well as the minimize the heat. How we are going to observe the heat? By supplying a lubrication oil. What type of lubrication we are going to use? So first one is called as a thick film lubrication. See here, first one is thick film lubrication, thin film lubrication, zero film lubrication, hydrostatic or externally pressurized lubrication system. So what is thick film lubrication? In between the journal and bearing surface, if I am going to use any lubricant oil, maybe the vegetable oil అవ్వచ్చు, లేకపోతే SAE 40 అవ్వచ్చు, SAE 60 అవ్వచ్చు, SAE 90 అవ్వచ్చు. So based on the type of lubrication oil, if you are going to supply it between the bearing and journal, that is called as a thick film lubrication. It is very important. Okay. So thin film lubrication. What is thin film lubrication? If I am going to use a lubrication oil, that lubrication oil will partially contact to the journal and bearing surface. That is called as a thin film lubrication. Okay, so what is thick film lubrication? If you are completely supplying a lubrication oil between the journal and bearing surface, that is called as a thick film lubrication. If I am going to use only lubrication oil over there in only partially contact between the two surfaces, that is called as a thin film lubrication or thin film bearings. What about zero film? So in between the journal and bearing, we are not supposed to use any lubrication oil. That means the lubrication is equal to zero. We cannot use any lubrication oil. Only the journal and bearing will be revolution takes place. That is called a zero film lubrication oil. What is hydrostatic? Hydrostatic means we are going to supply a lubrication oil by using additional system, additional any hydraulic or any pneumatic system, hydraulic system we can use to supply a amount of the lubrication oil from the outside to the bearing surface. That is called as a hydrostatic or externally pressurized lubrication bearings. These four are very important for gate examination, multiple choice question. Okay, not I'm MC question, multiple selective questions. Okay, so what is thick film? In between the two surfaces, if you're having any lubrication oil, that is called as a thick film lubrication. If the lubrication oil will there in only partial contact or partially lubrication oil is there between the two general and bearing surface, that is called as a thin film lubrication. If you are not having any lubrication oil, that means the lubrication oil is equal to zero. That means we cannot supply any lubrication oil to the workpiece. bearing and general surface, that is called as a zero film lubrication oil. What is hydrostatic? That means by using an external system, we can supply a lubrication oil to the bearing surface, that is called as hydrostatic lubrication oil. So these four are very important for your competitive examination. Okay, right. Next, see here, so when the journal bearing will keep on revolution takes place, we have a three stages. Okay, now what is the first stage? If the journal bearing is a rest condition, what happen? We have only small gap is there between this bearing and journal. That means both are in the same axis. That is the journal and bearing axis both are in a coaxial manner whenever the bearing will not start initial condition. Okay, so when you increase the speed slowly, what happened? See, the gap is somewhat very high compared to the uh, initial stage. The second stage, we're having a more gap. Why? Because of this journal will keep on revolution take place inside the bearing surface. So when you increase the speed in gradually, what happened? We have get more amount of the gap between these two surfaces. If it is a high speed condition, that means the speed will be continuously increased. If you are having a general bearing, that gap is somewhat very high. See here, okay na? So why? Because of this bearing and general axis are different. See here, this one is called as a bearing axis, okay, and this one is called as a general axis. See, this gap is called as a the distance between the journal axis and bearing axis, that is called as a eccentricity antam manam emantamu eccentricity antam. So based on this eccentricity, you are going to get more amount of the gap. If you are having a more gap, what happen? We can supply more amount of lubrication oil, meanwhile to observe more amount of heat in a less time. That means to increase the life of the component. So if you're having a less gap, we can supply only small amount of the lubrication oil, meanwhile it will take more time to observe the amount of the heat. Like that, we clearly analyze what is a general bearing lubrication process. Okay na? So in generally we are having a three stages in our general bearing. First one is called as a resting condition, slow speed condition, high speed condition. Okay, that is the thing we are going to understand. Okay, any doubt ma up to this now? Any doubt? Any doubt? Any doubt? Any doubts? Okay. So next, regarding bearing material. Okay, I think before manufacturing or before design a bearing, we need to select or we need to consider different types of bearing materials. That bearing material having some properties. Generally, we are going to use the different types of bearing material like Babbitt material, high temperature nickel, high chromium nickel, and rubber, plastic, wood. Like that, we are going to use different types of material. Okay. Before selecting any material of the bearing, we need to consider or we need to select some properties. Okay. So the main properties are compressive strength, fatigue strength, bondability, corrosion resistance, conformability, embeddability, thermal conductivity, cost and availability. These are the main properties we have to consider before selecting any properties of the material. So in that one, compressive strength. So always the bearing material, whatever the material, if you're going to choose in, that material having a more compressive strength. Why? Because of when you apply a radial load along the axis, that will resist to compress the material. So you should not avoid, should not develop any failure under a compressive strength or compressive strength. That's why the bearing material always having a high compressive strength. Okay, fatigue means what? uh, Varying loads or repeated loads. So with respect to the time period, we're going to keep on applying a load in a repeated condition. That means the material having a more amount of the fatigue strength, then only to avoid any cracks and failures. Otherwise, if you're having a less amount of the fatigue strength, it is very difficult to sustain the loads. Okay, bondability means what? So here bondability means whatever the material, if you're going to use in bearing manufacturing, that material having somewhat very hardness. That is, so if you're having a more number of layers or more number of what you call it as grains in the bearing, grains in the material, that will easy to resist the more amount of loading content. That is, the bondability is always very high. The bondability is mainly depends on the type of the hardness of the material. Okay, na? So corrosion means obviously very low. Why? Because of in bearing surface we are going to use lubrication oils. Okay, so the lubrication oil will create some rust formation. That's why whatever the material we are going to select, that material having a high corrosion resistance. Okay, na? Right? Sorry, low corrosion resistance. Right? Okay. Conformability, what is conformability? The material is free from any dust or smoke or any unwanted particle. Why? Because of the bearing will keep on revolving in a thermal heat sections, or any what called as automobile section or any other sections. No, that's why in that area the bearing material will not affect from any dust or any smoke or any foreign matters. So that is conformability. Embeddability means what? Embedded university, what here when the bearing will be running in a high thermal condition or any high heat condition, at the time the temperature will not affect the bearing material. That is called as a embeddability. And thermal conductivity, so that is the thermal conductivity is very less. So always you have to choose the material, the thermal conductivity is somewhat very less. If you are having more thermal conductivity, what happen? More wear and tear. Okay, na? So that is the meaning of thermal conductivity. Next, cost is always you choose only for the less cost of the material and easy to available in our market. Okay, na? So in this nine properties we are going to consider before selecting any bearing materials. Okay, that is the main thing here. And the next one is type of materials. See, high carbon chromium steel, chrome steel, stainless steel, ceramics, plastic, babbitt material, brass, branch. So almost we use all the material for different types of applications. In generally, nowadays the bearings are mainly manufactured by using a babbitt material. Why? Because of the babbitt material having a high hardness, high temperature resistance, high corrosion resistance, and also one more very beauty is to what you call it as to survive all the applications. All the application means if you are going to use bearings in any application in that area, that babbitt material will survive very easy. That's why we are going to use the main material is babbitt material. Next we are going to use ceramics, and next high carbon chromium steels, and sometimes high temperature nickel alloys. So based on this application we are going to use a type of bearing materials. Okay, so sometimes if you're going to write any RRB examination, at the time they will ask bearings are generally manufactured by using dash babbitt material. Okay, brass or branch, like that. Okay, next. So see, from this slide is very important. Why? Because of in our journal bearing, first we need to calculate what is the coefficient of friction. Generally, these coefficient of friction can be resolved by three scientists. One is called as Mackey equation, and Sommerfeld number, Petros equation. Okay, na? These three scientists will suggest the formula for calculating the coefficient of friction in our journal bearing. Okay, so before that one, the journal bearing is a function of three factors or three variables. First one is called as a bearing number. Bearing number. So the bearing number is simply identified by a symbol is called as a Z into N by P. Here Z is called as a viscosity of a lubrication oil. So please remember, Z is called as a viscosity of the lubrication oil. N means speed of the journal. P means what you call it as bearing pressure. Okay, na? So this entire formula we can call it as bearing number. and second one is diameter to clearance ratio. That means, see here, this one is a journal bearing, this one is a journal. So here this is called as a diameter of the journal. Okay, diameter of the journal. This one is called as diameter of the journal. Okay, so C means clearance. What is gap? The gap between the journal and bearing. Okay, that is called as a diameter to clearance. This D by C values you can take from a table or application. So if it is steam engine, the D by C value is nearly 0.002, like that. Okay, so in table C by D value is there. Based on the value, we're going to take a reciprocal, then you get a D by C value. Okay, so based on the application, we're going to take the value from the table, that is D by C value. Okay, right. L by D, that is the length to diameter ratio. This L by D ratio value also you can take from standard table. For example, if it is IC engine, the L by D value is nearly 100. Okay, na? So the L by D value and D by C values always take from the application. If it is steam engine, or if it is IC engine, or if it is marine engine, or it is petrol engine, or textiles, or agriculture. So in problem, they will give the application. Based on the application, we are going to take the values, then calculate what is the L by D value and D by C value. And finally, we're going to calculate what is the bearing number. So that is Zn by P. What is Zn by P? Z is called as a viscosity value. N means speed of the journal, and B means bearing pressure. So here, so in our design of the journal bearing, we need to find out two bearing numbers. Okay, one is from application, one more is from as per the given data. Okay, so from the table we have to get what is the value of Zn by P. So according to given data, what is the value of Zn by P? In these two values, what is the larger value? That is the final value of the bearing number. Okay, but before that one, we are going to calculate the bearing pressure. That is P is equal to load by area. See here, P is equal to 1 minute. See, P is equal to load by area. That is W by area A. That is equal to W by L into D. W by L into D. Okay, now L means length of the journal, D means diameter of the journal, W means radial load or load on the bearing. Okay, now so this is a P value. N means they will give what is the speed of the journal. Z means what is the viscosity they will give. Okay, now so based on this, we are going to calculate the these factors. But the coefficient of friction is a function of bearing number, D by C ratio, L by D ratio. Very important bit. So always you just remember. So the coefficient of friction is a function of bearing number, D by C ratio, and L by D ratio. Okay, na? Very important one. So I think from 2 years back, they will ask the gate exam bit. Okay, so the coefficient of friction may be expressed, or it is a function of A, bearing number, B, D by C ratio, C, L by D ratio, and D, all above. Like that, they will give one mark bit for your gate examination. So in last year I attempt JE examination. In the time also they will ask how to calculate the bearing number. Okay, na? Like that, for each and every examination, competitive examination, this general bearing, they will ask one problem regarding this, how to calculate the bearing number or how to calculate the coefficient of friction. Okay, na? I think all of understand. Bob, understand? Right. So next, here we have one small graph is there. So from this graph, we have to understand what is the bulk modulus. Okay, now what is a bulk modulus actually? So when you keep on applying a lubrication oil in between the journal and bearing, so whether the bulk modulus value is very high, okay, na? That is the type of lubrication is called as thick film lubrication. Okay, if the bulk modulus value is low, that is called as a thin film lubrication. Here in our x-axis, we have to take that bearing number, that is Zm by P. In y-axis, coefficient of friction, that is mu value. Okay. In x-axis, bearing number. In y-axis, friction. If, for example, see here, for example, it is point P. It is point P, it is point Q. This one is a point R and this one is point S. Here, see, for example, the point P to x-axis, we have a more gap or more value. If it is more value or more gap, what happens? More friction will be developed. Clear? So, whenever if you are having a more friction, what happens? We are going to provide a thick film lubricant. That means we can supply a more lubrication oil to the bearing surface. That is called as a thick film lubrication. So keep on the gap between the bearing and journal will keep on reducing. Take see here somewhat very less, here somewhat very less, here somewhat very less. Okay, and here also we have a less. So from the point P to point Q, what happened? Gradually reduce the amount of the gap or space between the two general bearing. Whenever if you are having a less gap, what happened? The thick film lubrication we are going to convert it into a partial lubrication. See here, from the point Q to point R, point Q to point R, what happen? Only the gap is somewhat very less. If you're having a less gap, what happen? We don't want the more amount of lubrication. That means we have to get only for the partial lubrication. See here, it is only partial lubrication. So afterwards, if you continue like this, from the point R to point S, again we have only small gap. See here, what happened? Again, we are going to use only for thin film. Thin film is only partial lubricant. I mean, it's only less amount of the lubrication we are going to supply. That means what I am saying is, based on the clearance gap between the two surfaces, we are going to use a type of lubrication. The type of lubrication is mainly depends on the bearing number as well as the amount of the friction will be developed. So these two terms are called as a bulk modulus. So when you design any general bearing, first we need to select or calculate what is the bearing modulus K value. So if it is a maximum amount of the friction or thick film lubrication, the bearing modulus K is equal to Zn by P, that is 15K, and then 15K is equal to bearing number, that is Zn by P. Okay, if it is a partial lubrication, that means only minimum amount of the bearing modulus, and that is equal to 3K is equal to Zm by P. It is very important. 3K is equal to Zm by P. Like that, we are going to calculate what is the bearing modulus. K is called as a bearing modulus. If it is maximum value, K is equal to, 15K is equal to bearing number. If it is minimum value, 3K is equal to bearing number. Clear? Okay. So based on the application or based on the given data, we are going to calculate what is the bearing modulus value. But in your mind, just you remember these two values. Sometimes they will give bearing number, ZMP value, or they will give viscosity value, speed value, pressure value. We have to calculate what is the bearing modulus. At the time, we are going to assume amount of the friction. If it is minimum or maximum, we have to use these two relations to find out the what is the bearing modulus. Okay, na? That is this slide. It is very important. So first, what is the previous slide? How to calculate a bearing number, D by C ratio and L by D ratio. And next one is what is the coefficient of friction, function of. Next one, how to calculate a bearing modulus, if it is maximum value and minimum value. Okay. And next one, see how to calculate the coefficient of friction. In previous case, we are going to use only what are the variables to consider a coefficient of friction. But in this case, how to calculate a coefficient of friction? According to Mackey equation, if you find out a coefficient of friction, mu value, that is equal to 33 by 10 power 8. See here, by using this equation, 33 by 10 power 8 into bearing number into d by c value plus k. Here k is not a bulk modulus, I mean bearing modulus. The key is called as a leakage value. This value is k is equal to 0.02. 0.02. It is only standard value for all the problems. Okay. So by using this equation, we are going to calculate what is the friction in our general bearing. This equation is called as Mackey equation. Okay. Right. One more is called as how to calculate critical pressure. Critical pressure means what? What is critical pressure? The pressure at which the bearing will be keep on revolving in a hydrodynamic condition. That means, so when you keep on supplying a lubrication oil, what happens? That lubrication oil will squeeze out, or the journal will press the lubrication oil. It will reach the maximum oil film. That is called as the critical pressure. So how to find out the critical pressure? It is very important. So in general bearing, when you find out the critical pressure or minimum operating pressure, that P is equal to Zn by 4.75 into 10 power 6 into d by c whole square into L by d plus L. It is a basic equation we have to use to calculate the minimum operating pressure or critical pressure. So definitely in this critical pressure or coefficient of friction or bearing number, they will ask one question. Okay na? So please remember these three formulas while you are solve any problem in our general bearing. Okay. So for getting a critical pressure, we have to use this formula. In this formula, Z does always, I think, know what is Z value, viscosity value. What is N value? Speed of the journal. I think all of you know. What is the diameter of the journal? Clearance gap, length of the journal. Okay, so I think all the values are there. Okay, just to substitute the values, you can get the critical pressure of the journal bearing. Okay, so next, Sommerfeld number is also one of the formula we can use to calculate the coefficient of friction. Okay, na? So already I told in that slide, by using three relations, we have to calculate what is the coefficient of friction. What is the first one? Mackey equation, Sommerfeld number, and one more is called as a Petros equation. Okay, so Sommerfeld number is this one. Okay, next, design procedure of general bearing for gate examination. I think we don't want all the formulas. We have to practice only three relations. First one is how to find out the coefficient of friction. Already I will explain. So second one is how to calculate a bearing number. Okay. Third one is how to find out the what you call it as heat generation or heat dissipation. Okay, now that I will explain. See here. So I think this formula all of you know. Okay. Next, how to find out the heat generation. That means, see here, this one is called as a bearing. This one is called as journal. Okay. When you supply a lubrication oil, before supplying lubrication oil, what happened? The journal is keep on revolution takes place or sliding takes place. What happened? Some amount of the heat will be generation. That heat is called as a QZ అంటాం. గుర్తుపెట్టుకోండి, ఇన్సైడ్ ద హీట్ ఏదైతే ఉంటుందని ఏమంటామో క్యూజీ అంటాం. ఓకేనా? బై సప్లయింగ్ ఏ అమౌంట్ ఆఫ్ లూబ్రికేషన్ ఆయిల్, what happened? Some amount of the heat will be dissipation coefficient, or the amount of the heat will be transferred to the atmosphere or absorbing takes place. That is called as a QD అంటాం. ఏమంటాము? QD అంటాం. This one is called as QD. So inside the heat QZ, outside the heat is called as QD antam. So when you find out the QZ value or heat generation value, we have to use the formula is QZ is equal to mu into WV. What is mu? Friction. Already we know. Whether we are going to use Sommerfeld number or Petros equation or Mackey equation, you have to calculate what is the mu value. Okay. Now what is W? Load on the journal. What is V value? What is V value? Velocity value. Velocity of the journal. That is equal to pi dn by 60. Okay, right? So based on this, we find out what is the QC value. Clear? Next, what is the heat dissipation? QD is equal to, that is QD is equal to C into A into TB minus TA. What is C value? Specific, what is called as heat dissipation coefficient. Okay, na? Heat dissipation coefficient. That value is nearly 13,342 1342 1420. It is standard value. Okay, 1420. It is called as a heat dissipation coefficient, that is C value. A means area. What is the area formula? L into D. What is TB? Bearing temperature, atmosphere temperature or ambient temperature. Okay, na? If you want to find out the TB minus TA, again we have one more relation. This is called as TB minus TA is equal to 1 by 2 into T naught minus TA, where the T naught is called as oil temperature, TA is called as ambient temperature, TB is called as a bearing surface temperature. Okay, so don't confuse. In our examination they will use three temperatures. One is called as oil temperature, bearing temperature, atmosphere temperature. Okay, our ambient temperature. Okay, so when you find out the T minus TA value, that will be equal to the 1 by 2 into T naught minus TA. Based on this relation, we have to calculate what is the QD value. Clear? Okay, so these four relations are very important in our journal bearing design. In our examination, in our competitive examination also, we don't want all the formulas. Okay, we have to know how to calculate the coefficient of friction. Okay, next how to calculate bearing number. Next, how to calculate a heat generation coefficient, and how to calculate a heat dissipation coefficient. These 4 to 5 formulas are important to find out what is the variables in our general bearing. Okay, right? Okay, I think all of you, I think all of understand up to this. If you have any doubt, you can ask. I will give 2 minutes time. So if any doubts in this one, just to ask. Otherwise, we shall move to next slide. Okay. సో ఇట్ ఈస్ వెరీ ఈజీ మా, ఎందుకంటే మెయిన్ కాంపిటేటివ్ ఎగ్జామినేషన్ కానీ గేట్ ఎగ్జామినేషన్లో కానీ బేరింగ్లో యూ హ్యావ్ టు గెట్ 1 మార్క్ వెరీ ఈజీలీ. సో సో యాజ్ సో ఫార్ వి డిస్కస్డ్ 3 to 4 కాన్సెప్ట్స్ ఇన్ అవర్ గేట్ ఎగ్జామినేషన్, దట్ ఈస్ స్పర్గేర్ అండ్ varying loads, principal stresses, principal strains, simple stresses, and one more is called as belt drives, and next one is bearings. So all these concepts compared to previous 4 concepts, this one is very easy to score. Okay, now 1 mark. So definitely they will give one question for bearings. Maybe it is a sliding contact bearing or a general contact bearing. So but so general bearing we have to complete. Roller bearing is will take more time. Okay, now so we have 1 more hour, then only we are going to explain very clearly. Okay, now for today class we have to explain only general bearing. Okay, now right. So see, next QG and this one is common. So generally they will ask problem like this. So in our last year previous year gate examination, they will ask problem like this. They will ask 2 marks question. Okay, na? See here. So the load on the journal. So here from the problem itself, first you clearly understand what are the variables they will give. Okay, na? So first one, load. Load means what? We can call it as P or W. P means pressure. Load means W. That is called as W is equal to 20,000 newtons. W is equal to 20,000 newtons. It is called as a load on a bearing or journal. Okay. So next is speed chart. What is speed? N is equal to 900 rpm. 9 is equal, N is equal to 900 rpm. Okay. So next they will give type of oil, that is SA10 oil. But here for oil, what is the viscosity they will give? The viscosity is 55 degrees Celsius here, 0.017. Here you are somewhat very what you call it as very clear. So corresponding this temperature, they will give the viscosity. What is viscosity symbol? Z. Z is equal to 0.017 kg per meter per second. Kg per meter second. Clear? Respect to this viscosity value, they will give the absolute viscosity, that is temperature. The temperature value is nearly Ta, that is called as Ta is equal to 55 degrees Celsius. Okay. Next, ambient temperature. That means this one is called as a bearing temperature. That means TB value, and one more is called as a ambient. That is TA temperature. That is equal to 15.5 degrees Celsius. Okay. Please keep in your mind. You have to. We are having a three temperature. One is called as a bearing temperature or absolute temperature. Both are same. Ambient temperature, and one more is called as a oil temperature or rising temperature. Okay, na? All right. So bearing pressure they will give. That is P is equal to 1.5 Newton per mm square. Okay. So and one more is called as a rising temperature. See here, 10 degrees. That is called as T. T is equal to 10 degrees Celsius. It is called as rising temperature. Okay. And heat dissipation coefficient. Japan NDC. C is equal to 1232 watt per meter square. Like that, first you write the given data very clearly, then only we have to calculate the remaining variables. But any problem we need to find out only for the friction. What is the friction? What is the friction? I think all of you know. That is, friction is equal to mu is equal to the formula Zn by P into 33 by 10 power 8 plus d by c, into d by c plus k. So I think all of you know all the variables we have. Z means viscosity already undi, speed they will give, pressure value they will give, and d by c value as per the application already I told. So for centrifugal pump application, what about C by D? For gate examination, they will give very clearly. Okay, na? Diameter value as well as the clearance gap value they will mention. No need to problem. Okay. Next, K means 0.02. So just you find out the friction value. Okay. So again, some problem they will calculate. They will ask to find out what is the Hg value and what about HD value. What about HD? Mu into W into V. Friction into load into velocity. What about velocity? Pi d n by 60. D already they will give. Speed they will give. You have to find out. What is HD value? HD is equal to, what is the formula? TB minus TA. TB minus TA. What about D minus TA? That is equal to 1 by 2 into T naught minus TA. From this relation, we are going to calculate what is the HD value. So the difference between the Hg minus HD value, it will give the net amount of the heat will be generation. Okay, na? So that means what is the amount of heat will be developed inside the bearing surface by supplying a lubrication oil. What is the amount of heat will be observing takes place. So the difference between the generation heat minus dissipation heat, it will give the net amount of the heat for our general bearing. But we need to find out what is the net amount of the heat. Based on this net amount of the heat, we can supply what is the mass of the lubrication oil. Clear? So for example, in general bearing surface, we're going to develop 1200 watts amount of the heat. Okay. But in this amount of the heat will be observing takes place, how much amount of the mass of lubrication will supplied? Again, we have one formula. that is called as Q is equal to M into S into T. Okay, M is mass of lubrication oil, S means specific oil gravity, T means temperature rise. From this relation, we are going to calculate what is the amount of the mass of lubrication oil. Clear? What about this Q? Q is equal to H. Already we know what is HRQ, both are similar. Okay, so already we know what is the amount of the net heat Q, but here we want to find out what is the amount of the mass of the lubrication oil. That means how much amount of lubrication oil if you can supply it to observing this amount of the net heat. That is the main criteria or main point, main variable we need to find out in our journal bearing. What I'm saying in the final is, we are as a design engineer, we are in a position to calculate what is the mass of the lubrication oil as per the required amount of the net heat. That is a very important gate examination bit they will ask in our main examination. Okay, that is what I am saying in this 1 hour. Okay, so like that they will ask the problem in our gate examination, and see if any doubt you can ask me. Okay, that is my today class. Okay, if you have any doubt you can ask now itself. Okay, so maximum in our general bearing definitely they will ask one question. Okay, general bearing as well as the sliding contact bearing. For next class, if you are having time, definitely I am going to explain how to design a sliding roller and general bearing. It is very easy, but compared to the sliding contact rolling contact bearing, the sliding contact bearing, especially general bearing, they will ask one problem. Okay, so in last year also the gate examination they will ask the problem on only general bearing. They don't want to ask any rolling contact bearing. Okay, that's why I'm going to first concentrate only on the general bearing concept. So in general bearing concept, generally problems they will ask problems only on these 4 to 5 concepts. That is how to find out friction by using a Sommerfeld number, Petros equation, Mach equation, how to calculate coefficient of friction, and next how to find out the amount of the heat generation, amount of the heat dissipation, net amount of the heat, what is the mass of the lubrication oil. Okay, so maybe sometimes if you are having luck or any fate, if you are having a good fate, so definitely they will ask one theory. The theory question maybe they will ask in what type of lubrication we are going to use. Okay, now what are the terms or what are the coefficient of friction terms we can use, and what are the types of properties of material, and one more is called as what is partial lubrication, what is full general lubrication, full general bearing, partial bearing, fitted bearing. I like that they will ask only some simple theory questions. Okay, but anyway, for gate examination, definitely we hope to get one problem on general bearing. I hope to understand all of you. Okay, thank you so much for attending the class. Okay, thank you. Have a nice day. Thank you. Bye.